What's up, you freaking geniuses? So let's talk about triangle altitudes and orthocenters. So an altitude is simply a straight line that goes from a vertex down to the opposite side, and it hits it at a 90-degree angle, right? So it looks something like that. Now, the cool thing about this is that it creates two separate right triangles. So knowing that, we can kind of use that to our advantage and use that to solve for different lengths and angles. And I'm going to go over an example where we do that. So we can also draw altitudes from our other two vertexes, right? So we can draw something like that and something like that, all right? So as you can see, all these three lines intersect. And when three lines intersect like this, we say that they are concurrent. And the point of concurrency, or in other words, the point where all three lines intersect, so this point right here, is called the orthocenter. Okay, so the orthocenter is where three altitudes intersect. And the orthocenter can be either inside the triangle, on the triangle, or outside the triangle. And that just depends on what type of triangle you have. So on an acute triangle like this one over here, the orthocenter will always be inside. With a right triangle, so I can draw my little right angle right here, the orthocenter will always be on the triangle. And specifically, the orthocenter will always be at this vertex, wherever that right angle is, okay? And for an obtuse triangle, the orthocenter will always lie somewhere outside of the triangle. Okay, and to show you where we get those from, let's start with the right triangle right here. So again, we can draw a straight line from a vertex to the opposite side, right? So we can draw something like that. Now, to draw an altitude from this vertex to this opposite side, you can see, if we draw something like that, this is obviously not a 90-degree angle. So what we have to do instead is just draw a straight line, basically just covering that side of the triangle until we intersect with this side over here. So then you can see that this side creates a 90-degree angle with this side, right? And same thing with this vertex over here. We can't just go straight across and hit the triangle over here. We have to just come straight down until we intersect this bottom side, and then you can see we create a right angle right there as well. Okay, so as you can see, all these three lines, so this side of the triangle, this altitude right here, and this side of the triangle, they all intersect at this corner of the triangle. Okay, and similarly with this obtuse triangle, we can draw an altitude from this vertex to the opposite side, so we have an altitude right there. And then again here, we can't draw a line like that because as you can see, we're not going to hit this side at a 90-degree angle. So what we have to do instead is extend this bottom line outward, so something like that, and then we can just draw a straight line straight down, and you can see now we have a right angle right there, right? Same thing with this vertex. We can't just draw a line like that. What we have to do instead is extend this line downward like that, and then now we can draw a straight line like that, and again you can see we have a 90-degree angle. Now, as you can see, these three lines don't intersect, right? So what we have to do is just simply extend each of them, and we should get pretty close to where all three intersect. So you can see they all intersect about here. So this point right here, again, would be the orthocenter. Okay, so for these two examples, we just have to name the orthocenter of triangle XYZ. Now, in order to find the orthocenter of any triangle, you need to find at least two altitudes, all right? So here we need to find at least two altitudes, and it looks like it gives us at least two, right? So it gives us this line right here, because again, it goes from the vertex to the opposite side at a 90-degree angle. Same thing with this one over here, right? It goes from the vertex to the opposite side at a 90-degree angle. So where these two intersect, as you can see, is this point right here at J. And the reason I told you we only need two is because the third altitude should always intersect at this point right here with those other two, okay? So as you can see, it gives us this other just random line right here. This isn't an altitude though, right? Because as you can see, it goes from the vertex to this side, but it doesn't hit it at a 90-degree angle. So this line right here that's drawn in is not an altitude. So if we drew in the altitude, we could see it would be from this vertex to the opposite side, and it would have to go through this point right here, right? So this altitude would actually look something like that. All right, now what about this triangle over here? So again, the big triangle is X, Y, Z, and as you can see, it tells us that this angle over here is a right angle, 90-degree angle. So you don't even have to check anything else. We already know that the orthocenter is on the triangle for any right triangles, right? And it's always going to be at that 90-degree angle. So we always know that the orthocenter for this guy is going to be right here at Y. All right, here's the last example we're going to go over. So here it says QS and PT are altitudes. All right, so let's find those first. So QS and PT are altitudes. So again, that means QS is an altitude, so that's a 90-degree angle right there. And PT, we would have a 90-degree angle right there. It also says that the measure of angle R is 55 degrees. So R right here is 55 degrees. What is the measure of POQ? So POQ would be this angle right here. All right, so remember, whenever we have altitudes, we create right triangles. So one right triangle I can see right here, I mean there's several, but one would be this guy right here. Okay, so triangle RPT. Now remember, all the angles inside of any triangle should always add up to 180 degrees. So here we know two of those. We know 55, we know this one is 90. So what must this angle up here be? Well, we could write this as angle P plus 55 plus 90, right? Plus 55 plus 90 has to equal 180 degrees. So here we would get that angle P plus 145 degrees is equal to 180 degrees. So here we can see that angle P would be equal to 35 degrees, right? So then this measure up here is 35 degrees. Okay, now if we find this angle right here, let's just call this Z. If we find this angle, we can use supplementary angles, right, in order to find this missing angle that we're looking for. So in order to find this angle that I'm just going to call Z, again, we have a triangle right here, right? So all these angles should once again add up to 180 degrees. So here we can say that angle Z plus 90 plus 35, right? So plus 90 plus 35 has to add up to 180. So here angle Z plus 125 is equal to 180. So we get that angle Z is equal to 55 degrees, right? So Z right here is 55 degrees. So supplementary angles add up to 180 degrees, right? So if this angle is 55, that means this angle must be 125 degrees, all right? So that would be the measure of angle POQ. Boom. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.